And without further ado, won't let me do that. It is time for Dr. Schaider to take over the reins here. Excited to hear what she has to say. Dr. Schaider is a senior scientist in environmental chemistry and in engineering at Silent Spring Institute. Her research focuses on characterizing PFAS exposures from drinking water, diet, and consumer products, and understanding the health effects associated with PFAS, investigating socioeconomic disparities and exposures to drinking water contaminants, and working with communities to develop research studies and resources to address their concerns. Dr. Schaider is a principal investigator for the PFAS-REACH study, and she also leads the Massachusetts PFAS and Your Health study, one of 7 projects within the ATSDR's PFAS multi-site health study. In addition, she co-leads the Community Engagement Core for the University of Rhode Island's STEEP Superfund research program. Before joining Silent Spring Institute, she was a research associate at the Harvard T.H. School of Public Health, where she's currently a visiting scientist. Dr. Schaider earned her master's and PhD in environmental engineering at the University of California, Berkeley, and a bachelor's degree in environmental engineering and science from MIT. And so without further ado, let's turn this over to Dr. Schaider to hear about PFAS in our water and where do they come from and what are the concerns. So welcome, Dr. Schaider.
Great. Well, thank you so much, Jeff, for the invitation to be here tonight. I'm just going to take a second here and share my slides. Can you see those okay?
Yep.
Okay, great. Well, I really appreciate this opportunity to be here and talk with you about PFAS in general and some of the work that Silent Spring Institute has been doing related to PFAS. Wish we could all be together in person and hope that I'll be able to come to a future meeting in person. But for now, I'm happy to be joining all of you via Zoom. So for my presentation tonight, I'm going to talk broadly about what are PFAS, where do they come from, what are the concerns. I'll talk about PFAS in drinking water, both across the country, across the state, and locally, including in Chatham. I'll talk briefly about several studies, and Jeff mentioned them already in my bio. Several studies that Silent Spring Institute has underway related to PFAS in water on the Cape. And then I always like to end with some suggestions for things that you can do and ways that you can learn more about this topic. So for those of you who are not familiar with Silent Spring Institute, we're a nonprofit independent research organization focused on understanding links between everyday chemical exposures and health. We were founded in the early 1990s by activists at the Massachusetts Breast Cancer Coalition who are concerned about elevated breast cancer rates on the Cape and wondering if there were environmental factors that might be related to that. So our work has really grown from those initial questions, and some of our work continues to be based on the Cape as well as elsewhere in the country. My background is in environmental chemistry and engineering, and so I've been working really closely on our water quality research program since 2009. So our work is focused on understanding endocrine disruptors, pharmaceuticals, and hormones, and other what we call emerging contaminants in the waters of Cape Cod, including ponds, groundwater, public and private drinking water wells, and septic systems. So PFAS have really been in the news a lot lately. I know they've been of concern lately, specifically in Chatham, but across the state of Massachusetts, there have been recent discoveries of PFAS in many public water supplies. This is from a Boston Globe article in May, reporting some of the initial testing of PFAS in public water supplies, and that those results found that 20% of the public water supplies in the state that serve at least 10,000 people had at least one sample of their water test above the new Massachusetts standard. I'll talk a little bit more later about what that new standard is. Closer to home on the Cape, and specifically in Chatham, in June, PFAS chemicals were found to exceed the Massachusetts standard in one of the Chatham wells. So I know this is a topic that may be of great interest to those of you living in Chatham. But stepping back for a moment, what are PFAS? Some of you may never have heard of them before, or maybe only recently heard about them. PFAS is a broad name. It stands for per and polyfluoroalkyl substances. I only say that once in each talk. And it's a class of thousands of different chemicals. And depending on the exact definition, in the case of EPA, they estimate there are over 9,000 compounds that are classified as PFAS. PFAS have been called forever chemicals. The reason for that is that they have many carbon-fluorine bonds, and those are very difficult to break down. And so what that means is that the entire chemical structures or parts of the chemical structures for PFAS are very resistant to degradation. So when they're out in the environment, they really just don't break down. And they do move through the environment. PFAS have been found in wildlife as far away as the Arctic and Antarctica. PFAS are not new. PFAS have been used in consumer products since the 1950s. So you may wonder why all of a sudden they're getting so much attention and are making so many headlines. And that's due in large part to the fact that they've emerged as common drinking water pollutants just in the past 5 or 10 years. As much as I would love to get really detailed into the chemistry, I'm just going to throw up a couple of chemical structures just for those of you who like a little bit of chemistry as well. So within this broad family of PFAS compounds, again, over 9,000 compounds, I'm showing up here on the right 2 specific members of this family, PFOS and PFOA. And these are the compounds that show up very often in water samples and in people's bodies. The blue zigzag is a carbon backbone to this chemical structure, and all those Fs show the fluorine. So you can see there are many places where the carbons and fluorines are connected together. PFOA was the chemical that was featured in the movie Dark Waters. And if you haven't seen that movie, I'd recommend that you watch it. It features Mark Ruffalo and Anne Hathaway and focuses on a community in West Virginia that had high levels of contamination of their drinking water from a DuPont plant that produced Teflon, and the heroic efforts of a lawyer to bring to light the concerns and the health effects of those exposures in that community. So you may not have heard of PFAS before, and we don't usually find PFAS on product labels, but PFAS are a part of our everyday lives. Some products with PFAS have names you might recognize, like Gore-Tex jackets, Teflon coated pans, Scotchguard or Stainmaster that you might spray on your upholstery or hiking boots. But a lot of products don't necessarily have PFAS on the label, so it's hard to tell which ones do and don't have PFAS. Things like dental floss, microwave popcorn bags, paints. Some of the most recent ones I learned about include guitar strings and rock climbing ropes. I'll talk mostly about our drinking water studies, but I did want to mention that Silent Spring Institute has conducted other studies of how people can be exposed to PFAS through food and consumer products. We led a study in 2017 of PFAS in fast food packaging, and subsequent studies linking PFAS exposures to consumption of fast food and use of oral B-glide dental floss and stain-resistant furniture. So pretty much every American that's ever had their blood tested for PFAS has been found to have PFAS in their blood, according to testing by the Centers for Disease Control and Prevention. One reason for that is that PFAS have very long, what we call half-lives in the human body. So the chemical structures themselves are very persistent, and then they also tend to accumulate in people's blood. For what we call long-chain PFAS, like PFAS, PFOA, PFAS that used to be added to products, these can stay in our bodies for years. Some of these have been phased out of production, although they do persist in the environment. And now manufacturers add different PFAS to our products that also are extremely persistent in terms of their chemical structures and can still persist in our bodies for weeks to months. All of this is concerning because of evidence linking exposures to PFAS with harmful health effects. Some of these effects include immunotoxicity, so decreased antibody response after vaccinations. And in communities that have had high levels of exposures to PFAS, there's a lot of concern with COVID that the vaccine may be less effective or that people in those communities may be more susceptible to infections. Other health effects include thyroid disease, certain types of cancer, increased cholesterol, small decreases in birth weight, ulcerative colitis. And something that has caught our attention as an organization focused a lot on breast cancer are laboratory studies that have linked PFOA to altered mammary gland development. We think that that may increase breast cancer risk. So this kind of shows the life cycle of PFAS. So PFAS are all synthetic man-made chemicals. So all of them start by being produced by industry. And there are a number of ways that we can be exposed. So PFAS can be used in consumer products that we can come into direct contact with, or the PFAS can migrate out of the products and end up in our indoor environment. We can breathe in the air or ingest dust that contains PFAS. PFAS can also get out into the environment through the use of certain firefighting foams called AFFF, through direct discharges from places where PFAS are manufactured or incorporated into products, and through the waste infrastructure as well. So we can be exposed through food, through water, and through consumer products. The Environmental Working Group has been tracking sites with PFAS contamination across the country. They've estimated that over 200 million Americans have some level of PFAS detectable in their drinking water. And they've tracked over 2,000 sites in pretty much every state with PFAS. So you might look at this map and say, why are some states covered with blue dots and other states don't seem to have any at all? And I wanted to point out that states like New Hampshire, Michigan, New Jersey, and North Carolina, in large part, have more dots because they've conducted more extensive testing. And in areas where you don't see dots, it may just mean that they haven't looked for PFAS yet. So what are the main sources of PFAS water contamination? So I mentioned already AFFF firefighting foams, also called Class B firefighting foams. These are used for fuel fires. So say if a plane catches on fire or an oil truck rolls over, and for training activities. So they're frequently found in groundwater near military bases, airports, and other fire training areas. So on the Cape, there are several locations where relatively high levels of PFAS have been found with respect to the use of AFFF. So the Barnstable County Fire Training Academy, the Barnstable Airport, and Joint Base Cape Cod. In other parts of the country, not so much on the Cape, high levels in the environment have also been associated with PFAS chemical production facilities and other industries, say industries that make PFAS-coated products. There are also a number of sources associated with lower level but more frequent environmental contamination, typically related to the waste stream. So discharges of leachate from landfills, sewage treatment plants and septic systems in areas where sludge or biosolids have been applied to land. So you might think with all this attention and concern and widespread exposure that certainly the EPA would have a standard for regulating PFAS in drinking water. Currently, there are no federal drinking water standards for any PFAS chemicals. In 2016, the EPA did establish a non-enforceable lifetime health advisory, kind of a recommended upper bound for the total amount of 2 PFAS chemicals. The 2 I showed you already, PFOS and PFOA. And they set that guideline at a level of 70 parts per trillion. The EPA does have to go through a very lengthy process in order to establish new standards. And they are pretty far along in the process of setting a standard for PFOS and PFOA. So I would guess that, that they will indeed set a standard for those 2. I'm not sure yet what that level might be that they would establish. As far as I know, they're not currently considering setting a standard for any other PFAS chemicals at this time. Many scientists and state regulators think that level is not strict enough in order to protect public health, and 12 states have established stricter regulations for PFAS in drinking water. Some of these regulations are enforceable, meaning that water supplies have to meet the standard. Some of them go beyond just PFOS and PFOA, and some set a stricter level, so 10 to 20 parts per trillion, rather than the 70 parts per trillion in the EPA guideline. So Massachusetts is one of those states. So last October, the state's Department of Environmental Protection set a standard of 20 parts per trillion for 6 PFAS chemicals called PFAS-REACH. And this is among the strictest standards in the country. So it includes PFOS and PFOA, which I've already mentioned, and 4 related PFAS chemicals. Because it's a standard, that means that there are monitoring requirements for public water supplies and steps that they have to take if the PFAS is detected above that level. It also includes financial support for public water supplies, recognizing that testing for and treating PFAS can be a huge expense for water supplies. And I was encouraged to see that there's also a requirement for review of new science every 3 years to determine whether it would be appropriate to include additional PFAS chemicals or if the standard should be adjusted to be even stricter. So because of this new standard, now public water supplies have had to start doing testing for PFAS. This may be a bit outdated, but the most recent time that I looked, over 600 public water supplies in Massachusetts had conducted PFAS testing. And of these, 51 had detected those PFAS-6 at a level that exceeded the state standard. That doesn't mean that the tap water in the distribution system exceeded the standard, but at least one of the samples coming from one of the sources in that water supply was above the standard. Many of these are municipal water supplies, but some are smaller supplies that serve schools, condos, businesses, or other institutions. So if you want to learn more about the testing that's been done, the DEP has a great website, and I'm happy to share my slides after the talk if you're interested to have these links, or you can go to the DEP website directly. So you can learn a little bit more about the testing that's been done and what that involves. And you can learn more about the water supplies where PFAS have been detected above the water supply. So this is just a screenshot, but you can zoom into Chatham, and Chatham is one of those supplies that had a detection above the standard for the PFAS-6. So you can learn more about those levels. And the state also has a website where you can find the results from the water testing that's been done. So I wanted to talk a little bit more in detail about what levels have been found in the various wells in Chatham, and there may be other people on the call who might respond to any very specific questions that people might have about the levels. So these are the results for the 6 PFAS chemicals that are in the Massachusetts standard. Just to get you oriented on the graph here, this is showing the parts per trillion. That green line is the Massachusetts standard of 20 parts per trillion. And what we see is that wells in different parts of the town have different levels of PFAS. So the South Chatham wells here and wells 6, 7, and 9 had either non-detectable or very low detection levels for PFAS in the samples that were collected in April. And then the wells that are more in the middle part of town are the ones where PFAS were detected. So there's wells 5 and 8 here. To be honest, I don't know which one is 5 and 8, but they're pretty close together. And then well 4, which actually has been offline for a number of years for other reasons. So these wells had levels that were of PFAS that were detectable, but below the 20 parts per trillion, about half, so 10 or a bit above. But then well 5 is the well that triggered the town to actually turn off that well because of a detection above the 20 parts per trillion. So after that discovery, the well was actually turned off. There has been subsequent testing at first that showed the PFAS actually went up. And then I don't have it on the graph, but more recent testing has actually shown that the levels are now in that well are actually below the Massachusetts standard. And thanks to Bob Duncanson for sharing this map and for providing me with some of the information for this, as well as I got some of this from the DEP website as well. So I'm really glad to see that the town is taking action to turn off the well and to make sure that the water is staying below the standard. I did want to put the Chatham results into a broader context because a number of other communities on the Cape and across the state have also had PFAS contamination, actually at levels that are quite a bit higher than what's been found in Chatham. So this next graph here shows the highest single sample for each of these public water supplies. So again, this is not necessarily reflective of the mixture of water in the distribution system, but just to give you some sense of how the highest levels in Chatham compare to the highest levels in other towns. So again, we've got the sum of the 6 here in parts per trillion. Now the bar goes up to hundreds of parts per trillion. So you can see that highest level here in Chatham that's over the Massachusetts guideline. It is actually below the EPA guideline of 70. And you can see that the highest levels in Chatham are quite a bit lower than the levels in Mashpee and in Hyannis. Hyannis actually had higher levels than any other public water supply in Massachusetts before they installed all the treatment that is now online. And some other communities in Massachusetts as well, Ayer, Westfield, and Hudson have all had PFAS coming in at in the hundreds of parts per trillion. So I just wanted to provide that context for the results that we're seeing for Chatham. So I've talked a lot about public water supplies, but some of you may have a private well. So I wanted to mention a couple ways that you may be able to get your water tested for PFAS if you're curious. So Mass DEP is offering PFAS testing to private well owners in 84 towns. These are towns where the majority of residents are served by private wells. So as far as I can tell, only private well owners in Wellfleet and Truro would be eligible for this. And I'm not sure what the status is in terms of their recruitment or sample collection. But if you're interested, I wanted to provide that information for you. I also wanted to mention that for a study that we currently have underway, we are also offering private well water testing. This is the STEEP Superfund research program that is led by the University of Rhode Island. STEEP stands for Sources, Transport, Exposures, and Effects of PFAS. Broadly speaking, the STEEP study is looking at how PFAS move through the environment, how we can detect them in environmental samples, how people can be exposed, and how they can affect our health. Silent Spring Institute is co-leading the community engagement core activities for the STEEP project, and part of our activities include a study of private wells on the Cape. And we're doing one last round of sampling this fall. So if you do have a private well and are interested, please visit our website to learn more and to sign up. And we did a prior round of sampling, and if you're curious to see what our initial round of results looks like, you can also find out about that on the STEEP website. I wanted to mention that STEEP has also conducted a webinar series. Our community engagement core has missed being able to be out in the community in person with COVID. So as a way to stay in touch with the community on the Cape, as well as people in other communities, we have a series of 4 webinars that we produced in conjunction with the town of Barnstable. You can find recorded webinars on the STEEP website. And I thought one that might be of particular interest was our most recent webinar in June, which included results from a study by our colleagues at Harvard University on PFAS in surface waters on the Cape, showing that especially near Joint Base Cape Cod, they found relatively high levels of PFAS in streams. And they found that a substantial portion of the total PFAS couldn't be accounted for by the known PFAS chemicals that we typically test for. So it suggests that there is a pool of PFAS that we're missing through much of our conventional testing. I know that this group is focused in Chatham, and so most of you may not live in Hyannis, but I did want to let you know about 2 studies that we have underway in Hyannis in case you might be eligible or you have friends or family who might want to know about these studies. One is called PFAS-REACH, which is Research, Education, and Action for Community Health. One of our main objectives for PFAS-REACH is to study how early life exposures to PFAS from drinking water may affect children's immune systems, including antibody response to routine vaccinations. So we're currently enrolling preschool-aged children in Hyannis, as well as up in Portsmouth, New Hampshire, where the Peace Trade Port also had contamination of their water supply by firefighting foams. So parents who take part will receive a report with their child's PFAS levels and information about their antibody levels, as well as gift cards. And here are some ways to connect with our team. And then the other study I wanted to mention is the Massachusetts PFAS in Your Health study. This is actually part of a multi-site study that's being funded and coordinated by the Centers for Disease Control and Prevention. So Silent Spring is leading one of 7 projects that will include thousands of people from communities that have had PFAS impacted water. This study will include both adults and children. We're going to be ramping up recruitment for the study in the coming months. And we're focusing on, again, on Hyannis and also the town of Ayer, west of Boston, where there was contamination from a Fort Devon site. So again, here's information for how to connect with the study. But regardless of where you live and the PFAS in your water, water is just one way that we can be exposed to PFAS. And there are some things that we can do in our daily lives to reduce our exposures to PFAS. There are some simple things we can do, like avoiding microwave popcorn and eating more fresh foods. When we're buying furniture or carpets, we can skip the stain-resistant coatings for furnishings. These are important steps to reduce our personal exposures and also to reduce the amount of these forever chemicals that can get out into the environment, either during their production or after their disposal. I've seen that a lot of the action related to PFAS is not necessarily regulatory, but rather coming from retailers. For instance, fast food chains that have promised to stop using food packaging with PFAS. So as individual consumers, we can let retailers know that we want products that don't contain PFAS or other harmful chemicals. But broadly speaking, this is not necessarily a problem we can shop our way out of. So thinking a little bit bigger picture, we need to support stricter chemical safety testing as well, to make sure that these very persistent kinds of pollutants don't get added to products in the first place. You can learn and share information about avoiding toxics, so by coming to events such as this and sharing what you learn. And also staying up to date about state and local legislation. For instance, there is a proposed bill right now in Massachusetts that would ban PFAS in food packaging in the same way that 5 other states have done. So if you want some practical hands-on tips for reducing exposures to toxic chemicals, you can check out our Detox Me smartphone app, which works on Android and iPhones, not just for PFAS, but for other types of chemicals as well. And if you want to learn more specifically about PFAS, I would point you to the PFAS Exchange, which has a variety of fact sheets, resources for PFAS impacted communities, and a data interpretation tool for helping to interpret the results of water and blood testing. Our partners at the STEEP Superfund Research Program have also produced a really helpful series of tip sheets for private well owners, families, and consumers in general. So with that, I'll wind down here and thank you very much again for the invitation. And here are a few web pages that you might like to check out to learn more about the topics that I talked about tonight. So thank you.
All right, thank you, Dr. Schaider. That was very informative. You're helping us with our mission statement of being an information source. So I have the chat up here. Let me get through the right screen. And so I have a question here from, let's see, oh, where'd it go? Come on. Frank. Oh, where did it go? I lost it. There it is. Sorry. So Frank asks, what was the 20 parts per trillion standard based on? And how does that filtration process, assume one exists, work to remove or lower PFAS?
Sure. So the 20 parts per trillion is based on toxicity studies in laboratory animals. PFAS and PFOA are among the most well-studied PFAS chemicals in terms of their health effects. And so there's a process that risk assessors use to go from laboratory studies where animals are dosed with different levels of chemicals, and then extrapolating from those into an amount of PFAS in water that with a lot of safety factors is not expected to cause adverse health effects. In terms of how well the filtration that various water supplies are using, or maybe home water filters that people use remove PFAS, I'll talk about a couple of different types of treatment. So one is activated carbon treatment. And that's used in pitcher filters you might have in your house, or solid carbon block filters under your sink, as well as that's the main way that public water supplies like the Hyannis water system have been removing PFAS. The activated carbon, particularly for the municipal supplies, does a really good job of removing the long chain compounds, again, the ones that have been of greatest concern, like PFOS and PFOA. The efficacy for household systems can be a little bit more mixed. In general, solid carbon block filters do a better job of removing contaminants. They have more surface area, but there can be some variations depending on water chemistry and the age of the filter. Again, there's a broad range of different PFAS chemicals, and the PFAS that are currently being added to products, some of them are what we call short chain. So they look a lot like PFAS or PFOA, but they're just a bit shorter. Or there can be other different variations on the chemistry. And the activated carbon filters can remove those, but typically not as well, or maybe the filters would need to be changed out more frequently. Some water systems have looked at other types of treatments, such as ion exchange resins. And for a household level, reverse osmosis can remove both the short and long chain PFAS. So
thank you very much.
Answer that question.
That was good. Thank you.
Sure.
And I think that answered a couple other people's questions too. Here's another one from Dan. Is there data to show how long consuming water with a 20 PFAS parts per trillion consumption level before significant health effects? Is it months, years, decades? Do we know?
So in the process of creating that 20 parts per trillion standard, that's based on an assumption of someone drinking that water throughout their whole lives. So it's not drinking it for a day or a week or a month. It's really intended to be protective of someone over their whole lifetime. There is evidence that for other types of health effects that might occur more at a developmental stage. So I mentioned studies that looked at altered mammary gland development in laboratory animals. The New Jersey Department of Environmental Protection, when they developed their standard, which was in the range of 10 to 15 parts per trillion for several different PFAS chemicals individually, they noted that the levels of PFOA that might cause impaired mammary gland development might actually be quite a bit lower than the level that they were proposing to regulate at. So the standard is intended to be protective over a lifetime, but there are concerns, especially for certain important developmental windows, that there could be effects over a shorter period of time.
Is there any research on, is ingesting it through water or, through the epidural layer in clothing or other materials worse than any other transmission vector?
Yeah, I'd say there's not a lot of information to answer this question. So we can ingest food or water that contains PFAS. We might breathe in PFAS that can be volatile and end up in the air. And we can also, there's not a lot of information about absorption through the skin. We've been fairly limited studies that seem to suggest that's not an important pathway, but I'm not really convinced that we, have a good handle on that. So, in terms of which is the most important pathway, it would depend how concentrated the PFAS were in the products and in the water, as well as the sort of relative ease with which we absorb the PFAS from these different pathways.
I'm gonna ask a question. You showed the graph of the various towns in Massachusetts, and their large PFAS numbers in the hundreds, and inside each one of those block graphs was a signature, if you will, of those 6 PFAS chemicals.
Mm-hmm.
What can you or can't you tell from the differences in the colors on that graph, because it's made up of different constituents of those 6 PFAS? Can you use that as a fingerprint?
Yeah, that's a great question, Jeff. To some degree, you can. It's not a definitive fingerprint, but for instance, the Hyannis water system or other communities where we know the main source of contamination is firefighting foam tend to be have PFOS and PFHXS as the most abundant PFAS chemicals. I think in those graphs, they were the ones that were orange and yellow. By contrast, communities like Hoosick Falls, New York, or Merrimack, New Hampshire, where PFOA was the most predominant pollutant, have a very different signature. So you can, to some degree, get a suggestion of what the predominant source would be. Looking at the results for the Chatham well that had the highest levels, to me, it looked consistent with it coming from a firefighting foam source. The highest concentrations were PFOS and PFHXS. It doesn't tell you where that exactly comes from, and it's not necessarily definitive. And it's challenging if there might be a mix of different sources, but it can provide some clues, and in some cases, maybe able to rule out certain types of sources.
Is the new someone's asking, is that New Jersey research published? If so, do you have any URL for it or a link or something?
I can. So they have, for each of their standards, they have a risk assessment document that's hundreds of pages long, where they've compiled the results from studies in laboratory animals and studies in populations of people who've been exposed. So that's on the web. I'd be happy to send a link to whoever's interested in that.
Perfect.
After I'm done talking.
And then I got one here from Dee Dee. Is bottled water tested? Do PFAS standards also apply to bottled water that is sold in stores? Assuming.
Yeah, no, that's a great question too. So drinking water from a public water supply is regulated under the Safe Drinking Water Act and regulated by the EPA, whereas bottled water, I guess, is considered food, and it's actually regulated by the FDA. And so I think in theory, that water is supposed to meet the same standards, but in reality, there's very little testing and really no enforcement of for PFAS in bottled water. So just because there's a picture of a pretty stream on the water bottle, it doesn't necessarily mean that the water is PFAS free. Sometimes bottled water comes from pristine locations, and sometimes it's just tap water that's been bottled and maybe treated. And I know there was a investigation in New Hampshire. The state of New Hampshire is actually looking to identify some bottled water that didn't have PFAS in order to make suggestions to people in an area that had water contamination. And they actually discovered a bottled water producer in Haverhill where the levels of PFAS were above the EPA guideline. So there isn't extensive testing. I know the DEP website has some results from bottled water testing that's been voluntarily provided by bottled water providers. So that can give you, I guess, some sense of at least bottled water that's been tested once for PFAS, but it's not consistent, and that testing was voluntary. If you're concerned about PFAS, I guess I generally tend to steer people more towards water treatment rather than towards bottled water.
Another speaker question here from Thomas Clark. Is the type of testing done regarding health effects of PFAS at all the same as the tests run to assess health impacts from other drinking water contaminants?
Yeah, I mean, a lot of the same methods would be used. We learn about the toxicity of chemicals in two main ways. So one are what we call toxicological studies. So these are studies of laboratory animals where we're able to make a pretty definitive link between a chemical exposure and the effect on the laboratory animal. Of course, the limitation with that is that our bodies are not exactly the same as mice or rats or whatever other laboratory animals are being used. But it does tell us about the ways that PFAS can affect biology, and we're not all that different than other animals in terms of our physiology. And then another important type of information are what we call epidemiological studies. So studies in people who've been exposed. And the studies that I mentioned, for instance, the CDC study is an epidemiological study. And so those are very valuable because, well, they're done in people. So we're more confident that the results are directly relevant to other people. But they certainly have some challenges in that they take a long time. It can be difficult, particularly for PFAS, which often are present as mixtures, to make a link between a health effect and one specific PFAS chemical. And because they take a long time, we're often looking back in time and realizing after the fact that there might be harmful effects of chemicals. For PFAS, because all of us basically have been exposed, some of the studies that I've seen have looked not just at communities with environmental contamination, but at the general population, and seen that there can be changes, sometimes subtle, but changes to our physiology as a function of PFAS. And really what we like to see are studies in laboratory animals and studies in people being consistent with each other. If you see laboratory animals getting testicular cancer from PFAS, and then that's something that you see in people, that gives us more confidence that those are real results and that they're relevant for people.
So I've got a little chat going on here, and it's not clear if it's going to everyone, but one of the questions was, can we confirm that the Chatham well with greater than 20 parts per trillion has been shut down? Frank said he thought it was being mixed with other non-PFAS wells, and if so, is that an effective solution in your opinion? in order to reduce that concentration?
Right. So the well that tested above the state standard has been shut off. That's my understanding, is that once it was found to be over 20, that it was shut off. I know that some of the treatment facilities for the town mix water from multiple wells. So, you know, and mixing happens sort of no matter what, and depending on where in the water distribution system you live, you'll get a mix of water from different wells. So, you know, blending a well with higher levels of PFAS with a well with lower levels of PFAS will mean you'll get an average of those concentrations. So, you know, in general, the ways that water suppliers handle having contaminated wells is either to shut off the most contaminated wells, to pump more water from the wells with lower levels, or to install some sort of treatment.
There's also some discussion about bringing some older wells back online too, as a potential as well. So,
right. Mm-hmm.
I'm not seeing. Oh, Dr. Duncanson, okay. Number 5 has been offline since the PFAS defect detection. We are investigating blending for possible future use, but no blending has occurred to date. So, thank you, Dr. Bob. So, we have anything else for Dr. Schaider at this point? I'm not seeing anything on the chat coming in. Anyone on the board? No? All right. Well, I want to thank you very much for taking the time to inform us. It's been very useful, and particularly all the resources that you've provided. If you wouldn't mind, if you could be willing to share your slides, that we could put a link to them or something on our website, and we do have a recording that we'll be putting up on the website as well, so you could see it through that if you want to access the recording. But we'll work to get some of that information up for everybody, so it's available for you. And in the meantime, Dr. Schaider, I just wanted to say thank you, and we're gonna send a Friends of Chatham Waterways water bottle your way for taking the time to spend your evening with us and inform us on PFAS. We really appreciate it. It was an excellent talk. Thank you.
Great. Thanks so much. Appreciate all the questions, and I'll look forward to my water bottle. Thanks.
Yep. Keep up all the good work out here on the Cape. Thank you.
Great. You too.
All right. And with that, I think we are reaching the end here. We're just about past the hour mark here. So there are some of the selected research from Dr. Schaider's website. And she provided her contact info as well. So I'll leave that in the slide deck as well. That'll be on the website. And again, I encourage you to visit our website, either to join or volunteer or donate. We really appreciate everything you do as members and volunteers, and we can't do what we do and what we want to do without you. So thank you for everything that you do, and we appreciate your time this evening, and have a good night and a great evening, and please stay safe. So with that, here ends the 2021 FCW annual meeting. Thank you everyone for joining. Have a good night.